3, 2, 1, blast!
You're probably wondering what a V2 rocket has to do with me restoring a vise, but I'll get to that later. My name's Chris, and welcome to the Lathe Machine Works. This week, I have a restoration of something that's not only a beautiful tool for the shop, but might be an actual piece of history. Over the past couple of weeks, German vises seem to have entered the YouTube zeitgeist, and I got pretty excited because I have a Heuer Primus vise that's been sitting in storage for a little while awaiting restoration. This vise is a Heuer Primus 150, which is 150mm jaw size. That's about 6 inches. Working through the restoration of this vise, I learned some pretty incredible things about the history of it, but let's save that for later. For now, I'm going to go ahead and start getting this cleaned up. Really all that's left on it right now is some of the old body filler. I'm not too worried about that because if that hasn't come off with the amount of wire wheeling I did, I don't think it's going to come off underneath the paint that I'm going to put back on top. What I'm going to do now is I'm going to use a little bit of Bondo to go ahead and fill in some of the imperfections in the forgings and some of the areas where there were welds. This filler seems like it's working really well. This is the Bondo plastic metal. It's just a one-part material, so you don't actually have to mix and blend like you would an epoxy-based body filler. But it seems to be filling in all the low spots really well, and once it hardens, it seems like it doesn't come off, so we'll see how this works. Now that I have all these forgings smoothed out a little bit, I'm going to let this cure overnight, and then tomorrow I'll sand and apply the primer. So unfortunately, I had to do a little bit of work off camera. We've been having some surprisingly cold weather for Georgia, and I had one day where the temperature got above 50 so I could get out and do some priming and painting. After the body filler was all set up, I used the die grinder and some Scotch-Brite pads to go ahead and get everything smoothed out, and then I hit it with some high build primer. I like my equipment to have a little bit of character, so I didn't polish off every ding and scratch. In case you're worried that you missed some interesting tidbit of information here, don't be, because I'm not good at this kind of work. I really just don't have the patience for body work and painting and prep and all that. To paint this vise, I'm going to use the same paint that I used on the metal wainscoting in my shop. It's this bare oil-based semi-gloss enamel in my favorite color, which is In the Moment. I picked this color in the first place after touring a 1930s textile mill in Porterdale. And this facility had some of the wainscoting on the walls painted with this color, and I color matched it based on a picture, and I really enjoy having this on the walls in my shop. This is kind of my unified color scheme that I have going on here, and it really adds to the vintage aesthetic. While we're watching paint dry, it's time to learn some history and figure out how this vise made its way all the way from Germany over to me here in Georgia. On this channel, I want to do more than just restore tools, but I also want to explore their history and figure out how it fits in with our industrial world. For some basics, this is a German vise produced by Heuer Primus, and Heuer Primus is still around, so I contacted them to get a little bit of information on this vise. They sent me some great information, including some old catalogs and some great videos, but unfortunately they weren't able to figure out what model my vise was. So, a little bit about Heuer Primus vises. Heuer Brockhaus began building vises in 1927. This design of vise was very unique compared to the cast construction of other vises at the time. Heuer Primus vises are forged from steel. Catalogs from the era show this vise is a bit different than mine, with curved jaws and a floating spindle nut that my vise doesn't have. Production of these vises occurred during the 1930s, and at the time, trade with Germany and America was very strong, up until about 1939. September of 1939. Hitler's armies begin marching across Poland, and the United Kingdom declares war on Germany. With the beginnings of an Allied naval blockade and unrestricted U-boat warfare, the Battle of the Atlantic had begun, making sure that there was no trade with the United States and Germany. As the war waged on, German industrial production shifted to focus on the war effort. By 1943, over 68% of German industry was focused on producing war material, and it was getting harder to bring in raw materials to Germany because of the blockades.
Strike at the railroad, for then the victim cannot mobilize. It cannot move men and supplies.
Quality started to suffer, and the fit and finish of material produced during the time declined. As the tide of war turned and the Allies marched across Germany, they instituted the destructive policy of dismantling the German war machine. Systematic dismantling of German industry occurred as Germany was divided into East and West. Heuer Brockhaus, located in West Germany, survived. And in a 1947 newsreel, vise production was shown in the Heuer Brockhaus facility. These vises were very similar to mine and had very similar shaped forgings. Differences in the design of my vise indicate that this is not a pre-war model manufactured during the 1930s. This model itself was actually patented in 1948. However, this doesn't provide an earliest date of manufacture because the Allied governing authority after the war had restricted German patents until 1948. By 1949, Heuer Brockhaus moved their production to a new facility using different tools and different machines, and I don't think my vise was produced this way because it still has some hand-finished features. A best guess is either my vise was produced during the war or immediately after it. The fit and finish of this vise is rough, which is consistent with the production of war material. So how did this vise make it all the way over to me in the United States? There's a couple of theories here. The first theory is that this is a West German industrial export. By 1948, the Allies had adopted a policy of production and economic growth and encouraged economic trade and industrial trade with the United States. However, the production of war-critical supplies, which included vises and machine tools, was restricted until in the 1950s. The more I learned, the more I got to thinking, and so I started tracing the history of this vise back, starting with me. And I traced it back to a swap meet in Huntsville, Alabama. As the Allies rolled through Germany after D-Day, there was a secret operation going on. The US and its allies were working to secure German industrial knowledge and trade secrets. See, the Allies trailed the Germans by about 10 years in their development of advanced aeronautics and rocketry. The V-2 rocket, which terrorized Britain during the war, was the most advanced rocket ever designed to date, and the Americans had to have it before the Soviets got it. This operation, Operation Overcast, was a program put in place to interview these German scientists that had been part of the aerospace industry. However, what the Allies learned is that the Germans were so far ahead of the Allied technology that rebuilding this technology without these scientists would be almost impossible. So The program changed from being an intelligence-gathering operation to almost an all-out plunder of German industrial resources and scientists. As the Allies moved through Germany, machines, tools, rocket parts, thousands of tons of documents, and over 1,800 scientists and technicians were gathered together for exfiltration into the United States. Over 2,500 tons of machines and tools were gathered up between 1945 and 1948, and these were shipped to Fort Bliss, Texas, and later transferred to Huntsville, Alabama. Do I know for sure that this vise was included in that 2,500 tons of machine tools shipped to Huntsville? No, definitely not. It's quite a coincidence, though, to find a German vise in Huntsville, Alabama, especially one that might have been made during the war. These vises are rare in the United States. The only ones that I've seen are either later production models or ones that were made in the 1930s, and my vise is not either of those. At the end of the day, though, this is all just a theory, and it takes a couple of leaps of faith to make it work. But I'd really like it to be true. If you have any ideas where this vise came from, or when it was made, or how it made its way to me, or even if you disagree or agree with my theory, go ahead and post in the comments because I'd love to hear about it and I'd love to get more information. Now, since the paint's almost dry, let's go ahead and get working on the lead screw. Taking a look at the spindle assembly, you can see that my vise doesn't have any kind of bearing here. It just has this washer here on the outside that helps to keep it from galling too badly as it spins. It does have a preload spring right here, and then this collar that's held in place by a little ring that fits into this groove. And that's what keeps this in place and keeps this nice and snug. The spindle bore here has an internal shoulder that tensioning spring rides on. Looking at this, it doesn't seem like it would be too difficult to add a needle bearing here. This washer is about 1/8 of an inch thick, so I might be able to find one. What I got here is some small needle bearings that are exactly the right size for this vise. This actually ended up fitting just an off-the-shelf stock size, and so this needle bearing and these hardened washers here will replace this thrust washer that was originally installed on this lead screw. This should help the lead screw turn a lot more smoothly even when it's being tightened down. Because this lead screw is kind of torn up, I want to take this over to the lathe and maybe even skim a couple of thousandths off the surface of it. I'd like a nice fresh machine surface here so it looks like it just came off of the factory floor. So as I was taking off these end stops here, I realized that this handle has been beat to hell and back. I'm going to go ahead and machine a new handle. I'm going to turn a shoulder on each end here to receive the end stop, and then I'm going to TIG weld these on the ends. It seems like every project these days ends up with something on the lathe. I guess it's good justification to have one in the shop. I have the lathe set up to turn between centers, so I have a hardened steel center put in the headstock of the lathe and in the tailstock. The lead screw of the vise was initially machined this way, and it actually has 2 holes, one at each end, ready to ride on these centers. Turning between centers is kind of an old-fashioned way to do lathe work. It comes from a time before CNC and before dial indicators were readily available to every machinist in the shop. The nice thing about turning between centers is you can pull your piece in and out of the lathe and flip it around without losing your concentricity like you would if you were to rechuck it in a 3-jaw chuck. This here is a lathe dog. This will clamp onto the workpiece and then slot into the slots here on the faceplate, and that'll be what actually spins the lead screw. This type of center here is a dead center, which means it doesn't rotate with the piece and it doesn't have any bearings. Lubrication is very important, and lathes were actually designed with this in mind. If you ever see these holes on the tailstock of an older lathe, that actually used to hold a little dauber to dip some lubricant out of there and put it on your dead center. And that lubricant that they used back in the day was white lead. I'm not using white lead in the shop because, well, it's not the best for you. I'm going to use some of this engine assembly lube, which is a high-pressure lubricant made with more modern materials. Didn't quite clean it up all the way around, but it came pretty close. I'm going to go ahead and take another 10 thou off, and hopefully that's going to be enough. I think at some point this lead screw has a little bit of a bend in it, because that's the only reason why it wouldn't be running true. Perfect. That ended up with a beautiful turn finish, and I'm really happy with that as the final finish of this. I'm not even going to polish this with any emery cloth or anything. While I'm over here, I'm going to go ahead and face off about 100 thou from this shoulder. That's going to accommodate the difference in the thickness between the needle bearing assemblies and what used to be there, this thrust washer. While I have the big chuck taken off the lathe, I'm going to use this mini Morse taper chuck here to hold the spacer here from the preload spring. This little tiny chuck actually works really well for holding small parts. This little chuck is held in by a 1 Morse taper, so it can't transmit very much force, but all I'm going to do is face this nice and smooth and maybe face off about 25 thousandths to help accommodate for another needle bearing. Alright, now I have a shorter washer. I've got the new handle, which is a piece of 3/4 inch bar stock, installed in the bigger chuck on the lathe. What I need to do here is turn some shoulders on the ends of this handle. The shoulders need to have a diameter of 400 thousandths, and that'll fit on those little ball end caps that came on the vise. I went ahead and got this all assembled and got the end caps welded onto the handle. And I've got to say, for 2 weeks of TIG welding, not too bad. A little bit of sandpaper and Scotch-Brite cleaned these up pretty well, and I think it looks pretty good. I've got 2 needle bearings here along with some hardened washers that came with them. These are going to be 2 assemblies, one for the front and one for the back. And before I install them, I'm going to go ahead and pack them with grease. I'm going to use some of this extreme pressure molybdenum graphite grease. This is the outer needle bearing assembly. These hardened washers will help keep the little rollers from digging into the steel. I don't know how well you can see this on camera, but back here is the retaining groove for the clip that holds this whole assembly together. It starts with the preload spring, which is fed all the way up inside there, and then this needle bearing. And lastly, this spacer holds everything in place. Getting this spacer ring to go into the groove is going to be a little bit of a challenge. I'm going to need to squeeze this preload spring pretty tight while I put this into place, so I think I'm going to use a gear puller to put some pressure on this. There it is, the ring's in the groove. This ring is locked in place, and as soon as I let the puller go, this should hold on tight. Let's see. This bolt here goes through the jaw. It pinches this part of the jaw down onto the ways so you can reduce this wobble. Well, I know I'm excited to have this piece of history cleaned up and put to good use in the shop. If you enjoyed this video, please consider subscribing because I have a lot more projects like this coming up and I think you might like it here. Thanks for watching.